Hi everyone, let's talk about today's LeetCode Daily Challenge. Today we have an easy problem, but it has a beautiful concept in graph theory. We will talk about it shortly. Let's read the problem. In a town, there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then the town judge trusts nobody. Everybody except for the town judge trusts the town judge. And there's exactly one person that satisfies property 1 and 2. You are given an array trust, where trust I is AI, BI, representing that the person labeled AI trusts the person labeled BI. So far, you should have guessed that we have a graph here, and a directed graph, not a simple graph. If a trust relationship does not exist in trust array, then such a trust relationship does not exist. So this means that it's directional. It's a directional graph. It's not bidirectional. It's unidirectional, every edge. And at the end, it's asking us to return the index, the label of the town judge. Let's look at the example. So for the first one, we have 2 nodes, 2 people, and the only edge we have is from 1 to 2. So let's go and see. So we have 1, 2. That's it. So this here 2 is the judge, because everyone else has an edge to 2. Everyone else is trusting 2, and 2 is trusting nobody. So 2 is the judge. The next example is we have 3 nodes, and we have 1 tree and 2 tree. So we have 1, 3, and then we have 2, 3. So again, here 3 is the judge, because everyone else is trusting 3, and 3 is trusting no one else. And the last example is 1, 3, 2, 3, 3, 1. 1, 3, 2, 3, and 3, 1. So in this example, 3 is not the judge. Although everyone is trusting 3, 3 is also trusting someone else, which is not one of the conditions. If you look at these examples, in terms of a directed graph, we see that judge should have in degree of n minus 1, which means everyone should be trusting the judge, and an out degree of 0, which means judge should not be trusting anyone else. All right, good. If you have read the book CLRS or any other classic books or books related to algorithm, this is a concept. This is a part of the terminology of graph theory. Let's go and look at it here. So this is a universal sink. The judge here is actually the universal sink. A universal sink in a graph is a concept from graph theory, often explored in directed graph. Okay, and it's a vertex or a node that has an edge coming from every other vertex. Every other vertex, just like our example, and just like our problem here, and has no edge going out to any other vertex. In other words, the in degree is n minus 1, and the out degree is equal to 0. This is exactly what a universal sink is, and this is exactly what our problem is asking for. So in order to find out the universal sink or the judge in our example, we just need to keep track of in degree and out degree. That's it. You just need 2 arrays to keep track of those numbers. Let's go and write the code. So we need 2 of them, 2 arrays, 2 vectors. Vector int in degree, n plus 1 and 0. N plus 1 because the nodes are numbered from 1 to n. The nodes are numbered here from 1 to n. So we need from 1 to n. And also out degree. And what we need to do is just iterate through this trust So it's going to be 4 auto. We have an edge. And then we will increase in degree and out degree of the corresponding nodes. Sorry, in degree of E1 and out degree of E0. So the edge goes from E0 to E1. So out degree of E0 is going to be incremented, and in degree of E1 is going to be incremented. And then we just need to check which node has these two properties. Okay, so we just need to iterate. And if we don't find such a node, we return -1. But here's the question. So here, number 3 says that there should only be one person who satisfies these two properties. But what we are doing is that the first index, the first node that has these two properties, we are just returning. Is that okay? The answer is yes. And because you cannot have two universal sinks, you cannot have two judges. Why? Because if you have two nodes without degree of 0, that means the maximum in degree in your graph is going to be n-2. Does that make sense? Okay, so you will have only one node that has these two conditions satisfied. And let's submit. Okay, that's it for today. If you like my explanations, please do subscribe, follow, and like, and suggest me to your friends who are practicing LeetCode problems. That means a lot to me. Thank you very much.